Yes, welcome to this new session in the OpenCV Python. Today we are going to see the new topic as a shape detection. Okay, so in this shape detection, we are going to detect the different shapes like a rectangle or the triangle or some sphere. Suppose if I want to detect a particular shape is present in my image or not, or suppose what are the different shapes present in the image that we are going to detect. Okay, so yes, yesterday we have seen the topic called as a color detection, so using which we are able to detect the color, okay, a particular color. So we have developed a mask, developed a mask using that track bar, and yes, we have calculated the mask for the red color, the green color, and yes, we have applied it on the image, and that using the bitwise ANDing operation, we are able to get only of a particular color only from that given frame. Okay, so yes, we'll start with the today's topic, and today's topic is the shape detection. Okay, so yes, let me share my screen. So yes, you should also start with the new project. So yes, I'm closing all this. Yeah, so yes, open the PyCharm. Open the PyCharm. Yes, I'm. Yeah, first open the PyCharm and create a new project. And yes, the today's topic is the shape detection, SHAPE detection. Okay, so create a new project. Create a new project as a shape detection. Yes, do with me. Everyone has to do with me. Create a project as a shape detection. So once you create the project, very first thing is, yes, I don't want this main.py file, because I'm creating my own py file. So yes, this default main.py I'm not going to use. So yes, delete it. So yes, I have deleted this file. Okay, now I want to install some libraries. Okay, because this project we can do with the help of the OpenCV. So yes, we have to install the OpenCV library. So yes, how to install? Yes, go to the in Windows. You have to go to the file and settings, and in a Mac or the Linux, you should go to the this PyCharm and the preferences. Open the preference. Open the preferences, and yes, go to this project. Shape detection, whatever the name is there, shape detection. Yeah, and open the Python interpreter. So when you open the Python interpreter, you are getting that what are the different packages already has been installed in your project. And yes, you can also control the versions. These are the versions. Okay, and yes, now just click on this plus button to install the new libraries. So just use the OpenCV-Python, OpenCV-Python, and click on the install package. So when you are installing the OpenCV-Python, this library, the NumPy library is the dependency of this OpenCV library. So yes, firstly, the NumPy library has been installed, and then after that, the OpenCV has been installed. So once we get the message as a OpenCV successfully installed, yes, we get the message, package OpenCV-Python installed successfully, close it. Close this window, and you can see here the NumPy and the OpenCV Python. These two libraries is present in my project. Okay, because we have created the project in a virtual environment. So yes, for every time whenever you are creating the new project, you have to install it. But suppose if you are doing the same, if you are using the same project for developing a different application, then no need to do the steps again and again. Okay, so here we have created the new project. That's why we are installing the OpenCV Python. So just click on the OK, and just right click on this project and just go to the new and Python file. So create a new Python file. Click on the shape detection, new, and the Python file. So give the name as the shape detection. Yes, you can give the any name. Okay, shape detection.py. This file has been automatically been opened when you create this file. Okay, now import the libraries that we require. So first one is import CV2, and the second one is the import NumPy as NP. Okay, these are the two libraries that we require for this project. Okay, so now write down the basic code that we required for getting the video capture. Okay, or getting the video frames. Okay, so yes, if you know that already, you can write down, or otherwise follow me. cv2 dot, yes, the function called as a video capture, and yes, you should give here the id of the camera. So yes, if I have installed only one camera, so id is 0. If you want to access the second camera, id is 1. If you want to access third camera, id is 2. Okay, like that. Okay, now just here I am mentioning the frame width also. Frame width width is equal to 640, and the frame height is equal to 480. So yes, because my camera is the HD camera, I don't want to be used that HD frame. I want to resize that HD frame to the 640 by 480. So that's why I have make this frame width and the frame height as 640 and 480. Okay, so just set it. So yes, by using the cap.set, I can set the width and the height of the given frame. So 3 comma, and yes, 3 is the ID of the frame width. So yes, I am setting the this capture device, whatever the capture device. So yes, I'm giving the command as capture the device, capture the frame with the frame height is equal to 640. Okay, and yes, and then cap dot set 4 comma capture the height. First one should be width. Okay, it should be width, and second one should be height. FRAME and height. Yeah. So first is width and the second one is height. Okay. Now next one is the while cap dot is open. Yeah. And then after that the first line is RET comma yes IMG is equal to yes cap dot read is the function through which we can get the image. Okay. So yes, we get that cap, we get the image. Now we want to display it. So yes, display it. So by using cv2.imshow, the window name I'm giving as the suppose original image. Yeah, so give the window name as original image, and then comma img, this frame, this image I want to display. And then yes, after that I think we have to wait. So yes, we have to use here if cv2 dot wait key of 1. So you should always use 1 equal to ordinal value of q. Okay, ordinal value of q. In some cases, in some Windows operating system, if it is not working, so you have to use the 0xff also. Okay, in some cases, in some Windows operating system, Windows 7 or Windows 8 operating system, actually the queue is having the size of only 2 bytes. So yes, we have to mask it with the ff only. So yes, we want only the last 2 bytes. So yes, the last 2 byte is compared with the queue. If it is the queue, then yes, we need to break it. We need to use the break. Yes, and then when it is break, so yes, we have to use the cap dot release, and the last one is cv2 dot destroy all window. Yes. Okay, so yes, I'm testing my code. So right click on the shape detection and click on the run. So everyone has to write down this code and just test it out. It is working or not. So now it is running. So yes, when it is running, actually, it will first time it will take some time because it will load the camera, and the new frame has been created. Yeah, so frame has been created, window is created, and now you can see here my yeah, so now it is more visible. Yeah, okay. So yes, these are different shapes here. So yes, I can able to get this frame with the width and height as a 640 by 480. Yes, are you getting? Yes, Chetan, Akash, Tushar, Aditya, Sachin, Aditya, yeah. Are you getting this with this code? Tell me. Are you getting the output? This is the bare minimum code, bare minimum code that we require, because we are doing the program for detecting the shapes real time. Okay, real time we are detecting the shapes. You should have some different shapes object. Like suppose I have taken the different shapes, like this is the circle. Okay, so these are the rectangle type. Okay, so these are the different type of shape. Okay, so this is the triangle, this is the small triangle. Okay, small triangle and the big triangle. Okay, so like that. Okay, so different shape you should ready with all these shapes, and then we'll process this image, and yes, we will detect the different shapes. So yes, are you ready with it? Yeah, so Sachin and Aditya got the output. Yeah, so Akash, are you getting? Okay. Okay, so now how to get shapes? That is the first question. To get the shapes, actually, shape is nothing but we are actually reading the we should able to get the outer edge of that particular shape. Okay, outer edge we are dealing with. Let's see this. I'm starting my camera again. Yeah, so yes, I want to detect the shape of this rectangle. So yes, I am interested with detecting the edges, external edges. Okay, external edges, I want this. So yes, can you tell me how to detect the external edges? Yes, yes, that method we already have taken. So can you tell me which method we have taken to detect the external edges? Edge detector. Yes, we have taken one edge detector. Yes, can anybody recall it? What is the name of that? Which edge detector we have taken? If you remember, so we have taken the one edge detector called as a Canny edge detector. So if you remember, Canny edge detector. So yes, by using this Canny edge detector, we can able to detect the edges of the given image, edges in the given images. Okay, so yes, just apply the Canny edge detector. So yes, but before applying the Canny edge detector, yes, we have taken we have pre-processed that image. Okay, how to pre-process? We have added, we have blurred that image. Okay, so yes, we have blurred the image by using the median blur or the Gaussian blur. Okay, so yes, I'm using here the Gaussian blur, GAU, Gaussian blur. Why Gaussian blur? Because when we are adding some blur, you will get the actually the better edge detection. Okay, if you are applying the same Canny edge with the original directly image, then actually you are getting the lots of the edges. But when you are adding some blur into it, so yes, the edges will be less edges will be you are getting. So it means that here we should add some blur to the image. So yes, we have already done this. So yes, add the blur. So yes, the kernel size we have given as a 7 by 7. We have already discussed about this. What is the kernel size? 7 by 7 or the 5 by 5 or the 3 by 3 or the 9 by 9. This can be you can take. Okay. If you get the better result by 7 by 7, or if you're not getting the better result over 7 by 7, you can get you can apply the 5 by 5 also. Okay. Okay, so when you are applying the 5 by 5, actually more blur will be added. So and the sigma value is 1, and yes, make the gray color, make it as a gray color, because Canny edge detector work on a grayscale image. So yes, img gray is equal to cv2 dot cvt color. Yes, and yes, it is a img blur, and then it is cv2 dot color. Yes, color of bgr to gray. Yeah, it is bgr to gray. So yes, show this cv2 dot im show, and yes, we have seen here blur image. I show the blur image img blur, and the cv2 dot im show again, and the yes, it is, I think, gray image. So always have a habit that yes, when you apply any blur or gray scale, yes, visualize that how it looks like, how it looks like. So yes, run it and see the output. So this is the gray image, this is the blur image, and this is the original image. So you can see the difference between this. So yes, this is the color and this is the gray image. So some blur has been added. Now you can see here the sharpness is more, but here there is less sharpness. Less sharpness in there. Yes, are you getting the output? Yes, type done in the chat box if you are getting this output. Now what we can do, we can create one horizontal stack here. We can create the horizontal stack. So h stack is equal to cv2 np dot h stack, np dot h stack, and yes, we'll add some img and the img blur, img blur. Or here img stack, and it is the img stack, and it is the output. So let's visualize it is working or not. So yes, I can able to see here the output in a single window. So we can add the img blur also, img gray also. So yes, how to add the img gray? So if you're adding img gray, actually it will not work. It will not work. img gray will not work. So img gray can be added by converting it. So like img gray is equal to cv2 dot cvt color, and then img gray, comma, the code is cv2 dot, yes, can anybody tell me, cv2 dot color gray to bgr. And yes, now we can able to see the gray image. Yeah, so here the all the three images, output images, we can able to see here. Yes, are you getting this? Now I'm waiting for 2 minutes. Just complete this code. Complete this code. And tell me once you get the output, tell me. Type done in the chat box. Yeah, so Aditya has got the output. Akash, Chetan, Shiva. Chetan, are you doing? Okay. Okay, so yes, now we can apply directly the Canny edge, Canny edge detector on the IMG gray. So yes, we will get that IMG Canny is equal to cv2 dot, yes, what is the name? The Canny. The name of the function is Canny, and on which image I want to apply IMG gray. And yes, that it is taking the thresholds. Okay, now this threshold will decide that what is the edges. The edges will be decided. So what amount of edges will be decided. So yes, we can decide the threshold, like for example, we can decide the threshold as 100 and suppose 200. Okay, so yeah, we are randomly taking this. we're randomly taking this thresholds, and yes, let visualize this img Canny. Okay, so yes, it is the img Canny, but img Canny also required to be converted. So yes, img Canny is equal to cv2 dot cvt color img Canny comma cv2 dot color gray to bgr. Okay, so let's see this. Okay, now you see here I'm able to get yeah, so I have to reduce some images. So blur image I don't want. Yeah, I'm removing this gray and the I want only the original image and the Canny image. So only two images I'm showing here for better result. Okay, so yes, my camera is not getting focus. So yes, let me make the focus of my camera. Okay, 1 minute. So randomly I'm taking that thresholds T1 and T2. So T1 is 100 and the T2 is 200. So yes, I'm adjusting the focus of my camera. Okay, so now, okay, so it is okay now. Now you see here, no, here it is clearly detected. Now here also it is clearly detected. Here also it is clearly detected. Okay. Getting this? Yeah, are you getting the output? We'll able to detect the edges by using this Canny edge. So just complete this code. So only one line, cvt.canny. But we have to define here threshold value. So here the T1 and T2 we have to define. So T1 and T2. T1 and T2. So we have taken the T1 and T2 as the 100 and 200. So T1 is equal to 100 and the T2 is equal to 200. So we have taken these values. But what happens, suppose now this value actually we are getting the output directly, but what happens in some cases you are not getting the proper result. So yes, you have to change the threshold. You don't know what is the threshold value. This threshold value 100 and 200 were taken as a randomly. Okay. Now we want to find out this value of T1 and T2. The best value of T1 and T2. So yes, how to find out the values of T1 and T2. So for this, yes, we will again use the same method that we have used yesterday. Yes, we will use the Trackbar to change the T1 and T2 value. So yes, create the first window, so called as a cv2 dot named window, and yes, we are defining suppose the parameters. Okay, so yeah, we were defining the parameters. Just cv2 dot resize window, and yes, the name of the window is parameters. Yes, is it parameter? Yeah, parameters, and it is 640 by 240. Okay, so yes, resize it, and after resizing, so you can create a track bar on it. So yes, create track bar. The first one is the threshold value 1, threshold 1. Okay, so yes, the second one is the on which window this track bar should be placed. So it is parameters. Okay, and the next one is the what is the initial value. The initial value is, suppose I am taking as a 150, or simply we're taking as 100, or the maximum we're taking as a 255. Okay, because maximum value is 255, and the last value is the empty is the function. As we have added the empty function yesterday also. So yes, add that empty function. So yes, empty x, and yes, only write down the pass. Okay, so it is an empty function only. Now one threshold 1 is created. Now yes, create the threshold 2 also. Second track bar, so it is threshold 2. the value is suppose 200 to 255. Okay, so maximum is 0 to 255, but what is the default value? Default value set it as a 200. Yes. Now just run it and check that we are getting that name window or not. So yes, this is my output and this is the my track bar. Okay, so yes, I can able to move that threshold 1 and threshold 2 values. Okay, so yes, but actually there is no effect. Why? Because we not read that values. Threshold 1 and threshold value we have only created, but we have not read that value. Okay, so yes, have you done with this? Are you getting this? Type yes in the chat box if you are getting the output from these 4 lines of the code. Just type yes in the chat box. Yes, I'm waiting for 1 or 2 minutes. Yes, Shiva, Akash. Now we have the T1 and T2 variables here. T1 and T2 variables. Okay, T1 and T2 variables. Now what we have to do? Yes, we just have to only use the cv2 dot get track bar position. Okay, we have to use the get track bar position. What is the track bar name? The track bar name is THER. Okay, it should be RE, na? It should be RE. RE threshold. Threshold. Yes, it should be threshold. THRESHOLD. Threshold 1. And from which window? So the window name is parameters. Window name is parameters. So yes, T1 I'm getting. And T2 also I want to get. So yes, T2 dot get track bar position. And it is THRESHOLD threshold 2. And it is the window name is parameters. The window name is parameters. And that's it. Now we can able to change the value of T1 and T2. Yes, type done in yes in the chat box. Type yes in the chat box if you have done this. Yes, Tushar, Shiva, Akash, Chetan, Aditya. Have you done this step? Are you with me? What empty stands for? Actually, the empty is the function which will be called when you change that track bar. Suppose there is a track bar and you change the track bar. So when you change the track bar, what should be happen? So yes, if you want to do that, yes, you can write down that here in the empty function. So empty will be called whenever you change the value of the track bar. Yes, Akash, are you getting? Now we don't want to be do when we're changing it. So that's why we are only writing the empty function here. So empty is just a name. Okay, you can give the name as Akash also. Yes, you can give here the Akash as a function. Yes, you have to define the Akash function. Yeah. Getting this, Akash? Yeah. Yes. Are you done this? Have you done this? Yeah. Aditya, Sachin, Chetan, Shiva. Yeah. Okay. So yes, let me run this and let's see the output. Now you see here what is the output. Yeah. Okay. Now actually we have not printed that value. So let's print the value of T1 and T2 also. Print T1 comma T2 to get the values of threshold 1 and threshold 2. Yes, so here we are getting that values -1. Now it is -1 and -1. Now rearrange all these parameters. Now it is -1 and -1. Now threshold 1 and threshold 2. Okay, there should be some mistake because I'm changing this position, but I'm not getting the values. Why? Because there should be some mistake. METRS, yeah, it should. So, parameters and threshold 1, threshold 1, yeah, and T1 and T2. So yes, let's run this again. Now this spelling mistake, actually, if you are making a spelling mistake, you are not getting that values. No, I'm also not getting the values. Let me check it one more time. Yeah, are you finding? Yeah, anyone getting the output here? Because I'm not getting the output here. The spelling mistake is the only problem. So PARAMETERS, PARAMETERS. So yes, actually, yes, I'm making all the as a copy paste only. Copy paste, and then the THRESHOLD1 and THRESHOLD1. THRE, it is a space is there, so there is space. I have taken the extra spaces. I have given here the extra spaces, that's why I'm not getting the output. Now here you can see here I'm getting the output as 100, 200 is the values, and now if I'm changing this value, you see here the more edges will be detected. So these are some thresholds. Now if you want to detect only this, so you should know the values, extract values. No, I think it is 100 and 140, so it is good. 100 and 200. Yeah, 100 and 200 is good. Yeah. Yes, are you getting this? Aditya has got. Akash, Shiva, are you getting the output? Okay. Okay. So yes, now what we will do, we want to find out the contours present in the image. Now, what is contours? The contours are nothing but the shapes. Here, the shapes is having the different name as a contour. Okay, so it means that what are the closed shapes are there? Closed shapes. We are interested in the closed shapes. What are the closed shapes, or which are the closed shapes present in the image? That we want to find out. So for find out the contours, actually there is a function called as a get contour. Okay, find contours, not get contour. Find contour is the function. But before applying the find contour on the image, on the Canny image, yes, we have to dilate that particular edges that we have detected in Canny. Okay, so because whatever the edge we have detected, its width is very small. You see here, what is the width? The width of this edges is very small one. Okay, so you can consider is a very thinner edge is there. Now if you want to make it as a somewhat block, okay, like here you see here there is this where is it? Yeah, here. Now here you see here, due to the shadow, actually due to the shadow, the different edges is detected. Different edge is detected. Now I want to remove this. I want to remove this. If I want to remove these false edges, now what you have to do, you have to dilate that image. Now how to dilate that image? If you want to dilate that image, so you can use here the function called as a cv2.dilate. Now what do you mean by dilate? The dilate represent that, so you are making the edges as some bigger one. Okay, so like I'm using the kernel. kernel, and the iterations equal to 1 or 2. Okay, so yes, these are the actually things that you can vary. And the kernel I'm defining as the np dot once 5x5. Okay, so this is the kernel of 5x5 having the all ones. Okay, so yes, I'm dilating that. Let's visualize that. What is the output? img dilate. I think it is img Canny. No? So yes, we should make that as a grade 2 BGR. So it is the img dilation is equal to cv2 dot cvt color, and the img yes, it is the dilation comma cv2 dot color bgr grade 2 bgr. Okay, grade 2 bgr, because it is a type of the only single channel. So yes, now you see here the difference between this Canny edge and the dilation image. So here the outer edges are somewhat thinner one. Okay, so yes, if you have the thinner outer edges, now you can able to yes get the proper output or the correct output. Yes. Okay, now you see here. Yes, are you getting? Okay, so I have dilated that output. I have dilated the output. So are you getting the output, dilation output? Now next one is very simple. Now we have to apply the that fine contours, and yes, by finding the contours we will able to detect the what is the number of edges present for that particular contour. Okay, so we'll find out that. So yes, but before this, yes, have you got this output up to this? Are you clear with this? Tell me, type done in the chat box. Yeah, up to this dilate. If you are not getting the output, yeah, so you can yes change the iteration, number of iteration. You can make it as a 2 or 3. So once you are making the iteration more, actually the thicker will be, the more thicker line will be there. Okay, so now the next one is the now we will write down one function called as gate contours. Gate contours function, and yes, gate contours function, and yes, we will give the input as a image dilation, and the we'll give the again one image. We'll give the one image as a img contour, which is the exact copy of the original image, because on the original image we are drawing that particular contour. Okay, whatever the contour we are getting, we will draw the contours on this image. So that's why I want the copy of the contour. img contour is equal to img dot copy. I want the copy of the original image. Yes, so this is the img contour is the copy of the original image, and this image, the copy I'm giving to the gate contour function. Okay, now what the gate contour function will do, gate contour function will get the different contours from the dilation image, and yes, once we get the coordinates of the contours, what we'll do, we will draw the contour, all the contours on the img contour on the original image. Yes, are you getting this? And yes, we will display that also. We'll display it also. So yes, what we'll do, yes, so we will remove this img Canny, and yes, we'll only displaying the img dilation and the img contour. So three images we will display. So let's write that definition. Let's write the definition. Definition get contours. It will take the img dilation and the img contour. Contour or contours? Contour only. img contour. Yes, define the function img and the img dilation, or simply you can use as img only, or img dilation is okay. So it is a dilated image. So just define one function. I get a definition get contours. And just we have to apply the function called as a find contours. Find contour will function takes the different argument as a img dilation. The second argument is the mode, which mode you want to use for find out the contours. So if you want to find out the outer edges, the best mode is the cv2 dot retr underscore external. So if you want to find out the external edges, if you want to find out internal edges, so there is an internal method is there, but now we want external edges. So yes, retr underscore external, and then the method that we are using here as cv2 dot chain approximate null. So this method we are using for find out the contours. Now this function will return the contours and the hierarchy. Now we don't have to deal with this hierarchy, HIE, RA or CHY. Okay, hierarchy. Now we want CONTOURS. Now we can find out the contours, so we can print out that contours directly. Okay, so what this contours? TOURS. It should be TOURS. CON. It should be CON. Contours. Again, it should be CONTOUR. Contour. It should be again contour. Contour. Yes, I always write down that contour. So it should be contours. 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 CONTOUR. And yes, where it is? CONTOUR. Okay, so make that spelling mistake. Actually, I have made the spelling mistake. Contour. The correct spelling is the CONTOUR. Contour. So make it here. Contour. Okay, get contours and get contours. Okay, so contour. Yeah, all are correct now. So I'm getting that correct from this find contours. CONTOUR. So just let's print these contours. Print the contour. So yes, img contour. Yeah. So the output, and get unexpected argument count as a img contour. Yeah, it should be this. It should be same as here. Now you see here, I'm getting this is the output, and yes, I'm getting the different contours. So yes, I'm giving here only one. Now here I'm able to get the only one contour here. These are the coordinates. These are the coordinates of the contour. Okay. So yes, these are different contours. Actually, I have not drawn the contours. That's why you are not able to see it. Yes. So it means that I'm getting the coordinates. I'm getting the coordinates by using these contours. Yes. Are you getting this also? Now we want to find out the contour. We want to iterate over this contour. Suppose there are the 3 or 4 contours are there, or 3 or 4 shapes are there. Contour is nothing but the shapes. Okay. So now there are 3 or 4 shapes are there. Now we want to draw each and every contour. We want to draw each and every contour. Now how to draw the each and every contour? Very simple. So we have to iterate over that contour. So yes, for C and T contour in the contours. Okay, so for every contour, so yes, I'm reading the first contour. The CNT is having the its coordinates of the first contour, coordinates like its x and y coordinates. Okay, so yes, first I will find out the area of the contour. So yes, CV2 dot contour area is the function which will give the area. Okay, which will give the area. So yes, we'll print that area. We'll print the area, and let's see that what is the area of that contour. So it will print all the area of the contours. Okay. Now this is the area. You see here the area is there is some small dot is also there. 100, 100 and 200. Why 100 and 200 is printing? Yes, we have actually printed that T1 and T2. Now just make it as a comment, T1 and T2. Now you see here there is only one contour, only one shape is present. Only one shape is present, and that's why I'm getting only the area of that one shape only. Okay, so if I'm adding one more shape, you see here, if I'm adding one more shape, so this is the second shape, the two shapes area I'm getting here. First shape is having 23,400 something, and second is having the 2,000 and something. Okay, yes, getting. So yes, I'm getting the area also, area of the contour. Now suppose there are some small contours are there, so some small contours. So small contour can be considered as the noise. Small contour area can be considered as a noise. Okay, let's make one, take an example. Now you see here. Now you see here, this is the, I want the shape of my this multimeter, but there are the shapes are there, the middle shapes are there. Now these are the noise, and this contour I don't want, these contours I don't want. So now we can filter out this also. So if the contour area is less than a particular threshold, then I don't want to print that particular contour. Getting that? I don't want to print that particular contour. Okay, now you see here, now if you want to print the contour, you can directly print out by using the function called as a cv2 dot draw contours. Very simple. And yes, on which image you want to print img contour. And the next one is, what is the coordinates? The coordinates are present in C and T. Its index I'm not going to use here, -1. So use all the index from the C and T. That's why I'm giving here -1. Okay, and the next one is the color. The color you can decide as any color. So I'm using the color as this. And the thickness I'm giving as a 3. Okay, now you see here, it will draw all the contours, all the contours. Small contours also it will draw small contours. Yeah, you see here, it is on pink color. All small contour also it will draw. Okay, if I remove this, there is no contours, but if I added this one, you see here, all the contours it will draw. Yeah, Now I want to filter out this. If I want to get the area of this area of this rectangle only, then I don't want this smaller contour. So what I can do, I can make one statement like this. Yes, I can use here, if area is greater than 1000. If area is greater than 1000, then only draw the contours. Then only draw the contours. Otherwise, don't draw the contour. Very simple. Now again, check with it. Now you see here, it is 1000 is very less. So we have to make it as a 5000. Now you see here, the remaining one is not being, some will be, so this is the big contour actually. Yeah. You see here, the area which is having, now I can print that area also. Yeah, you can see here. I'm printing the area inside this only, inside this. It will draw the contours which is having the area greater than 5000 only. Now you see here, there is no other area which is less than 5000. All the area is greater than 5000. So yes, all the contour that I'm getting here having the area as a greater than 5000, greater than 5000. So if you want more, so you can, what you can do, you can again change this value, like suppose 15,000 or the 10,000. Okay, so 10,000. So this will be gone. Now you can again make it as a suppose 20,000. You can play around with it. Okay, so it is 20,000. So no area will be actually correct. So what we can do, we can add one track bar. We can add one track bar here. Here I am making this here. And I am drawing one track bar as a create track bar and the area. What is the area? Area. And it is a para METERS. And it is suppose starting is suppose 2000 to suppose 20,000. And the function is called empty. And here what I'm doing here, I'm using here the function called as a area minimum is equal to cv2 dot get track bar position, and it is the area that I want. And yes, what is the window name? Window name is parameters, parameters. Okay, and yes, instead of giving this 20,000, give here the variable area minimum. Yes, what I have done here, I have added one track bar called as area. Starting value is 2000 up to the 20,000. And now this area minimum I have read it here in the for loop. And yes, if area is less than area minimum, then if area is greater than area minimum, then only draw the contour. So let's check with it. So yes, this is the area. Okay, so area. Now I'm increasing the value of area. Now here there is no. Okay. Okay, now you see here only the outer edge will be detected. Outer edge will be detected. The inner is not detecting here. Inner is not detecting because you see here Actually, this inner is also having some area greater than this one. Okay, now, okay, inner is also having. Let's again change. Yeah, let's change it again. Yeah, now the inner is not detecting. Now you see here. Okay, only the outer is detecting. Getting that? So it means that you are filter out the smaller contours. If you want to filter out the small contour, you have to use this statement. If area is greater than area minimum, then only draw the contours. Yes, are you getting this? So yes, for your reference, I'm giving this find contour function in the chat box. You can copy paste from this. Okay, so we have find out the contours. We have draw the contours also. We have draw the contours and we have the area of that contour also. Okay. Now we want to find out. The bounding rect. We want to find out the exact shape of that particular contour or exact shape. Like it is a rectangle or it is the triangle. So yes, how to get the it is rectangle or it is triangle. So if you are reading any contours and if that contour is having the only 4 points, it means that it is either square or it is either rectangle. Getting that? If the contour is having the 3 points only, 3 points, it means that it is it is triangle. Getting that? So yes, I want to find out that particular approximation. Now how to find out the approximation? To find out the approximation, so we have to use the function called as a cv2.arcLength. And yes, we are giving here the length, and yes, close or not. So we want a close shape contour or not. Yes, we want the closed shape contour. So yes, use the true. If there is only single line, that will not be considered now. Okay, so yes, we want only the closed contour. Yes, the perimeter of that closed contour will be calculated. Perimeter. So what is perimeter? The perimeter is the addition of all the edges. So that is the perimeter is calculated. And yes, we were calculating the approximation by using the function called as a approx poly dp, which will take the c and t. Okay, c and t. First argument. Second argument is the one value we have to give here. Epsilon value I am giving here as a peri. Yes, this is the standard one. I have find out these values from this internet. And yes, I want the closed shape. So what is the approx contains? What is approx contains? Now I don't want to print this area. I want the length of approximation. So what is the length of approximation? So length of approximation contains the how many points it contains, how many points this CNT contains, contour contains. So yes, if it is the rectangle, it should be 4. If it is rectangle, it should be 4. You see here, I'm having the rectangle. Here. So I'm getting the 4. So now I'm bringing the triangle here. Triangle. So yes, triangle for triangle, it is 3. For triangle, it is 3. And here it is, I think, polygon. So yes, the corners are 8. So yes, I'm getting the how many corners are there. Yes, are you getting this? So by using these corners, I can able to get the what is the shape of that particular contour. Yeah. So yes, are you getting this? So yes, I want to check only the length of approximation. Now yes, I can draw the one rectangle over it also. So which is actually which contour we have detected. We can draw one rectangle, bounding rectangle, which will have the enclose in that particular rectangle. So it is called the bounding rectangle. So yes, bounding rectangle can be get by using the function called as the cv2 dot bounding rectangle, and yes, we are giving here approx. So yes, I will be telling you what is bounding rectangle when I'm displaying it. So yes, I'm getting here I'm drawing the rectangle over that particular shape. Whatever the shape is there, I'm drawing the rectangle over it. Okay. So if there is a triangle, yes, I'm drawing the rectangle over the triangle. Okay. So yes, IMG contour on which I want to draw the rectangle. Yes, its PT1 is the X and Y, and PT2 is the X plus W and the Y plus H. Okay. And the color I'm giving as the green color 255,0, and the thickness I'm giving as a 3. Okay, thickness I'm giving as a 3. Now let's run it, and I will be explaining you what is bounding rectangle and what is the use of it. Yes, now you see here. So let me remove that original image, or simply dilation image also I'm removing. Original and contour. Yeah. Okay. Now you see here, I'm getting the bounding rectangle on. So this is the detected shape. Okay. So just I'm moving here. Now this is the detected shape. Okay. So this is the detected shape. Okay. This is the detected shape. Okay. So if there is 2 or 3 more shapes are there, these shapes has been detected. So we have drawn the different bounding rectangles over it. Are you getting the bounding rectangle? So yes, using the bounding rect function, we are getting this X and Y. XY, that is the starting position. This is the starting position. And what is the width and what is the height? Width and the height. Yes, students, are you getting this? Just add these 2 lines. Type yes in the chat box if you are getting this output. Now we can actually print out something output. Okay, so yes, like put text IMG contour, like how many points we have detected. So points is equal to, or points and plus str of the length of the approx. Okay, and then yes, what is next? The next is, I think, origin. Okay, so origin I'm defining as x plus w plus, and the 20 is the, so yes, and it is y plus 20. And next one is the font scale. Font scale is the CV2 . So I think it should be y plus 20. Okay, and then after that it is CV2. Font space is CV2 dot font, and then the next one is the font scale. So you can use the font scale as 0.8 or 0.7. Okay, how much font you want. The color I want to display it as again green color, and the thickness I'm giving as, suppose, the 0. Okay, so this is the point, and yes, we can copy and paste it here, and yes, we can print the area also, area. And yes, area can be print by using the int of the area. And some we have added. I'm modifying only the x and y, which is printed. Yeah. So yes, you can directly copy paste this whatever I am writing here. Now by just look at the output. Okay, now you see here, these are the points and the area. Okay, so yes, I'm displaying only one. Okay, so 4 points and the area is 29,000. Let me change the color. The color taken as a red color. Take the color as a red color. Now you see here, there are 4 points and the area is this. Okay, now you see here, what is this? 3 points and the area is this. These 8 points, area is this. Here 3 points, here 3 points. Getting that? Yes, students, are you getting this? Yes, I'm giving this function to you. Now what you can do, you can again, if you are not with me, you can just copy paste this function from the chat box and you can run it directly. If you are getting any errors, you can copy paste from the chat box and you can directly run this program. Okay, and type done in the chat box if you have done this thing. Now what is remaining? The remaining is, now we want to identify its shape. We want to identify its shapes. So yes, how to identify its shapes? So I can again write down here, if the length of approx, if the length of, or simply we can use here one variable, we can take one variable like the ages is equal to, okay, ages point is equal to length of approx, okay. And yes, so we can use the switch case. Yeah, no, there is no switch case here, so we can use if else. Yeah, so if the ages equal to 3, if it is equal to 3, so if it is equal to 3, then yes, can you tell me? So yes, what we have to print? It is, what is the shape? Yes, can anybody tell me what is the shape? If ages equal to 3, then the shape is triangle, triangle, triangle. And yes, it is 20, 45, and I think it is 40, 65. Make it as 65. Now again, you can use the else if ages equal to 4, then if ages equal to 4, then it is the rectangle. It is the rectangle. It should be elif. Again, it is elif. If ages equal to 8, and then it is polygon. Polygon, and that's it. Otherwise, you can also use the another elif statement like elif. If other than this 3 points, else, then unknown. K-N-O-W. Yes, see here, students. Yeah, we have used the edges to determine that what is the edges. If the edges is 3, then print the rectangle. If edges is 4, then print the rectangle. If the edges is 3, triangle. If the edges is 4, is rectangle. If the edges is 8, polygon. And yes, any other things, there is unknown. Okay, so let's run this and let's see the output. Okay, so yes, I am giving here. Okay, let me adjust my camera. So yes, what is this? This is rectangle. Rectangle. Okay, this is rectangle. Yes, what is this? This is triangle. Yes, this is triangle. Yeah, what is this? This is polygon. This polygon. Yeah. What is this? This is rectangle. It's rectangle. Okay. So why it is saying unknown? Because actually we have to reduce that area, increase or decrease the area. Okay, it is taking 5. Okay, 4 or 5, 4 or 5. Actually, that's why the output we are not getting properly. So number of points is 11. So your number of points, area is unknown. You see here. Yes, multiple. Yes, getting the points. Yes, so it means that we have successfully find out the shapes of the given shape of the given shape. Yeah, shape of the given shape. Like it is a rectangle or triangle or what. Okay, by using the OpenCV. Yes, any doubts in this? Yes, I'm giving this whole function again in the chat box. So actually it is very big function. So I'm not able to copy it. Not copy. Copy and here paste it. Okay. So I have given the code from the edges. Edges equal to length of origin. So has anyone getting the output? Yes, Chetan, Akash, Tushar, Aditya. Yes, anyone getting the output? So I think if you have the web camera, then only actually you can able to visualize the output. In case suppose if you are using your web camera, okay, web camera from your laptop, actually it not be possible to get because the camera direction should be at the it should be directed towards the floor. Okay. So yes, try this code on the web camera. So just you can buy the web camera from very up to the 500 to 600 rupees only. That also work because we are using the very less resolution 640 by 480 only. That is the VGA camera also work. So yes, students, yeah, have you done? Type done in the chat box. Have you understood? Type yes in the chat box. So you have to yes do this program after getting the web camera. Once you have the web camera, you can able to practice it. Yes, Aditya, getting? Okay, so yes, any problem or any questions from this?